Question K1.2. Let's see what's going on here. Let's get going. The first part, what we had to do was a sketch of a speed time graph. Okay, speed against time. Speed is going to go on the y-axis. Time is going to go on the x-axis, the horizontal axis. It's a lot of text. This is a lot of reading through to get the key information that we need to be successful at this task. Going through, the first thing we see, the first point we're dealing with is point A, and we have, when we're at point A, we're at 15 meters per second squared. So I can put that 15 in the graph because that's my initial speed. Then, and I've put it in red. Note, the other next piece of information that's useful is the fact that it's 120 meters away. It's useful, but it's not useful for the graph. That's something we're probably going to use for part B or part C. Not sure as yet, but for part A, for sketching a speed time graph, we're not putting the distance in the graph. We don't need that. But I've highlighted it. It's going to be useful at some point. We know there's uniform deceleration. That means that from 15, I'm going to have a diagonal going downward. The thing is going downward to what number? And that information comes right after when it says that I'm going down to a speed of 5 meters per second. So I can label 5 meters per second in my diagram, draw that diagonal. I now have clearly a motion where I started at 15 meters per second and I went down to decelerated to 5 meters per second, and the deceleration is uniform. That's why I have a diagonal. Okay? And I could put in dashed lines just to make everything a bit clearer. And now let's move on. Let's see what else happens. After that, I'm at a point W. We don't label the points in the graph either. We do not need to put that in, and I just reflected and thought maybe I'm talking a bit too fast. So I will slow down. I get too excited sometimes. Forgive me. Okay. Slowly. Uniform acceleration for 16 seconds. That's what happens after. So that speed is going to be going up. I'm going to have a diagonal going up. To what? To V. And it also tells me that this new speed I'm going to get to is more than 15. So I need to put V in higher than 15. And then I could do my diagonal going up. That shows constant acceleration going up to V equals to V. And that's happening for 16 seconds. At this stage, I can put in the time for the first leg of my journey, and I'm putting that time as T. Why am I putting it as T? Because, well, reading through the text, they haven't told me what was the time for the first leg of the journey. Okay? They haven't told me, so I don't know what it is. I'm using my dashed lines just to make everything clear that this is the first leg for T seconds, this is the second leg for 16 seconds. What happens next? Maintains a constant speed. Constant speed is a horizontal line at V. And that is for 22 seconds. So I can put in my line, label my time, this line, constant velocity, constant speed V for 22 seconds. Just putting the dash lines. You don't have to put them, but it does help make everything a bit clearer. Is there anything else I need to put in? No, I have gone from A to W to B. I don't label A, W, B in the diagram. That's not necessary. That's it. That's what I need. I have all the key information they gave me in my speed time graph. I'm confident I have 3 marks. 1 mark for the V shape, so this for having this shape here, that will give you a mark. The second mark for the last 22 and making sure that V is more than 15, so having this bit higher than at the 15 mark. And then the third mark is about having the right figures, having the 16 to 22 to 5 to 15. That's where you get your 3 marks from for drawing this graph. Let's move on. We'll move on to part B now. Part B is asking me to find the time taken for the car to move from A to B. Wow, I want the whole time. Now, we already know that the second leg is 16 seconds and the third leg is 22 seconds. So really, first part of answering this question is we need to find T. We need to find how long the first leg was. And then we can add that to 16 and 22 to get the whole journey time. So that, what do I have? What information do I have? This, all of a sudden, the distance is useful now. It is useful. Okay? For 120 meters, I know that I had 15 meters per second, then going down to 5 meters per second, and that was for a time t. Okay? I saw that point W is at 120 meters away. It's 120 meters away, and I'm going from 15 down to 5. You can see it here for that time. I can use S is equal to half U plus V times T to get the distance. Substitution, you end up with 10T is 120, which means that T is equal to 12. Think about what I've done there. Okay. T is equal to 12, straightforward. And then the total time will be the 12 plus 16 plus 22, giving 50 seconds. So your final answer, the time taken to get from point A to point B is 50 seconds. It took 12 seconds to get to W, and then another 16 and 22 to get to B. M1, M1, A1. That's how the marks are distributed for this particular. So 2 method marks and 1 accuracy mark, showing that you knew how to use the half U plus V times T properly, showing that you had the right method in terms of adding up all the times to get 50. That's the second method mark, and actually doing the addition properly, getting the accuracy, that gives you the third mark. Finally, big one, 5 marks. So far, let's just go back slightly. So far, we got 3 marks for part B. Okay, now we're going to get a big 5-mark question. It's asking us to find V. Wow. How do we go about doing that? Okay. We know from T equals 0 to 12, the distance was 120 meters. Okay. We can find, using S is equal to half U plus VT, we can find the distance for the second leg, and we can also find the distance for the third leg. Okay? And that's what we're going to do. That's what we're going to do. That's what's going to give us our solutions. For the second leg, we have 5 plus V. Okay? Those are my 2 velocities. I started at 5. I went up to V. And that took place over 16 seconds. So once you do the substitution, well, then you're going to get 40 plus 8V. You don't have to do the substitution at this stage. That's my approach. You can just bundle everything up in the end, because you're going to add all the distances to get 1,000 meters. Yes, you're going to have to convert kilometers to meters, okay? But that's S2. The second leg of the journey is 40 plus 8V. The third leg, and I've been really explicit writing this down because it should be obvious to you that if the velocity is constant, that the distance, the displacement, is just going to be 22 V. It's going to be the area under that section, which is just 22 V. Okay. So though that's my second and third leg, and my first leg was 120, adding together, I'm supposed to get 1,000. Okay? That's what's supposed to happen. So continuing, when we look at simplifying this, we get 30V is 840, and that means that V is 28. Okay? So that's the strategy, and as I said, if you wanted to have, you didn't have to simplify first. You could have just plugged everything in and make one long equation and then simplify. That's fine. In terms of marks, 3 of the marks were dedicated to you getting up to the right equation in terms of having the 120, having the 22V, and either half. You didn't have to simplify this, but getting to this stage would have given you 3 marks, and then getting this right simplification and accurately solving the equation would have given you the next 2 marks. Okay, so that's how the 5 marks are roughly distributed. As I said, you didn't have to do it exactly the way I did it, but once you got to the stage where you had the right equation that simplifies into 30V equals 840, you would have had the first set of 3 marks. Okay, so there you go. That's number 2 sorted. Hope that all made sense and you make your corrections with whatever you got wrong. If you got everything right, be smiling. You're well on your way to doing absolutely fantastic in M1 in mechanics.